Now, empirical means experimental. So what we're going to be looking at is substances where we determine those coefficients experimentally. That's what empirical means. So let's take a look at the steps and we'll at least introduce this concept. The law of constant composition states that a compound will always have the same relative mass of constituents. The percent mass will be the same regardless of the source. And what that means that in a chemical formula, we're always going to have that same ratio. Now let's talk about some terminology before we move into calculations. We've seen molecular formulas. Now, a molecular formula tells us exactly how many of the atoms are bonded together one to another. So if I had something like, I'm going to go ahead and start with the structural formula so I can work this out for you. A structural formula determines or tries to depict a two-dimensional drawing of a substance. So in this case, I'm going to do an alcohol. It's easiest to show one of the words we're going to talk about right here. So this happens to be an alcohol called 1-butanol. And this would be its structural formula. Its molecular formula would be C4 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, H10O. So that would be our molecular formula. Now, a term that we're not going to see a lot, but which you need to know at this level is isomer. So you want to find a way to get it on the list of things you have to keep in your mind until that May test and hopefully further if I've done a good job. Those are things that have the same molecular formula but different structural formula. So an isomer of our 1-butanol would have this same molecular formula but look different structurally. So I can actually move that OH over one carbon, and I'd have an H there and an H here, and there's actually quite a few different isomers of this. I'm looking at one of those, H and an H. Do you see I moved this hydroxide? You'll learn that's called a functional group. And I moved it over one carbon, and in the process I lost a little carbon there. So we need 4 carbons if we are going to have the same formula. So that would be an H and an H and an H. So you notice that the OH is now on a second. Doesn't matter which direction you number from, we would call that the second carbon. So this would be 2-butanol, and it's the same molecular formula, but it's a different structural formula, and these are isomers of one another. Now, an empirical formula is the lowest whole number ratio. Now, in our case, this is the empirical formula. So the molecular formula and the empirical formula are one in the same. Let me give you an example of a different one. If I have benzene, benzene is C6H6, that's its molecular formula. If I drew that for you, we would have a ring of 6 carbons. It's actually a resonance structure, and we'll have to refresh your memory on that later. And then off of each carbon would be a hydrogen. So that's a benzene ring. Its molecular formula is C6H6. Its empirical formula would be CH, the smallest whole number ratio, since there 6 to 6 is 1 to 1. In the first part of the experiment, you would find that molecular formula. Now, I like to use this little symbol of EFU. That's my number of empirical formula units. Let's go back to our benzene example. If our empirical formula showed we had C1H1, I hope it's clear to you that it would take 6 of these little empirical formula units to fit into the molecule. So these calculations are going to require 2 steps. Step 1 is going to be to find the empirical formula, and step 2 is to find this whole number of empirical formula units so that we can find the molecular formula. And we will be doing this in 2 ways, and we will address that in our next